Here is an application problem to find minimum distance between airplanes. The question is, a light airplane flying east at 300 kilometers per hour passes over Toronto Airport at 12 noon, 10 minutes before a second airplane flying south at 420 kilometers per hour passes over the same point. Assuming that both the planes are at the same altitude, at what time is the distance between them minimum? So let's first try to sketch the scenario. Let's say this is the y-axis, which is towards the north, and this is x-axis towards east. So here we have two planes. One is flying east. So flying east with 300 kilometers an hour. So let's assume this is the plane which is flying east, and the speed given to us is 300 kilometers an hour. That means if time is t, then the distance covered will be 300 t, correct? So it will be 300 t along this direction. On the other hand, there's another plane which is flying south, which reaches this point 10 minutes after. Right? So it must be a bit away 10 minutes before when this crosses Toronto Airport. So let us assume that it is at this location, and the second plane is flying south, and the distance it is covering is at the rate of 420 kilometers an hour. So with time it takes 420 t the distance, right? You know, distance is speed into time. So remember your triangles. So whenever you do distance, speed, time, make a triangle here on the side and say, well, distance, speed and time. So distance, speed and time. So distance is product of speed and time. Speed is 420 kilometers an hour. T is t. So that is the distance covered. Now what we are supposed to find is that any instant of time, what is the separation between them? Let's say this is the separation between them. So let me say S be the separation between them. Now clearly this is a right triangle, and therefore the separation is, let us say this is y value from here to here, and this is x value from here to here. Then the separation S is y square plus x square, square root, right? That is the separation between the two. Now what is y value? We need to figure out. X value we know, it is 300 t, right? So y is what? So we need to find what this distance is when the first plane flying east just went over Toronto Airport. So that should be 10 minutes before. So since the plane is flying south with the speed of 420 kilometers an hour, in 10 minutes, how much distance can it cover? 10 minutes means t equals to 10 minutes. 10 minutes actually means 10 over 60 hours, right? Or 1/6 of an hour. And therefore, that distance should be, because in 10 minutes covering the whole distance. So the distance, let's say, should be, let's say y, I should say capital Y, for example, should be equals to 420 times 1/6, right? That should be equals to 420 goes by 6. 42 is 7 times 6, so we get 70. So now we know that this distance is 70. So from here to this point, it is 70. And therefore, what is y equals to? Y should be equals to 70 minus 420, correct? And therefore, we get small y is equals to 70 minus 420, correct? And as we know, x is equals to 300 t for us, right? Distance covered by the plane moving east, right? Let me just push this page a bit on the right. Okay, so now it's very clear to us from the diagram that we have a right triangle with S being the separation, and S is equals to square root of x square and y square. Add them up, right? Now, what is x square and what is y square? X square is the distance covered by the plane going east, which is 300 t. So we can write this as 300 t whole square, plus y is the initial distance of 70 minus the distance covered by the plane moving south. So it is 70 minus 420t whole square, correct? So that becomes the separation at any instance of time t, right? So t belongs to real numbers and t is greater than 0 and t is after 12 noon. That is what time t is, correct? So to find the minimum or maximum distance, we need to find critical point. That means we have a equation in terms of one variable, which is time. So let's find what is ds dt equals to. So ds dt will give us a critical point when equated to 0. Now it is half of this function to the power of minus 2. So I can write all this in the denominator, right? So let me just draw a line here, and in the denominator I'll copy all this, which is 300t whole square plus 70 minus 420t whole square. And in the numerator we get derivative of inside function, right? So the derivative of this is 2 times 300t, so it is 2 times 300t times derivative of this, which is 300, correct? Plus 2 times 70 minus 420t, correct? Times derivative of this, which is minus 420. So that is what we get. Now as you can see, we have to equate this to 0 to get a critical point, correct? So for critical point, it should be equal to 0. Now this whole thing equal to 0 means numerator should be 0. Is that right? So numerator should be 0. We can simplify this a bit. That 2 can get cancelled with these 2's, right? Anyway, so what we're trying to show now is find a critical point. That means the numerator of this should be 0. So the numerator, we get to multiply this and equate to 0. So 300 times 300 is 3 times 3 is 9 with 4 zeros. So we get 9, 2, 3, 4 zeros, t. And here 420 times 70. So let's use the calculator. 420 times 70 equals to 29,400. So when you multiply this, you get negative sign. So we get 29,400. Now 420 square with positive sign and t. So plus 420 square, which is equals to 176,400 t. That should be equal to 0, right? That is what we get. Now we can combine these terms and we get 90,000 plus 176,400. Let's add them up. Plus 90, 1, 2, 3 equals to, we get 266,400 t equals to 29,400. Okay. Now from here we can find what t is. So t is 29,400 divided by 266,400. So let's do that. 29,400 divided by 266,400. We get 0.11. So this is equals to 0.11, right? So that's what we get. Now at this point we could have maximum or minimum distance between the two. So we need to test this out. So what we will do is we'll just test the value of this function around this point. So we'll take a point closer to this. As you can see, ds dt is that numerator over this denominator. Now denominator is a square root function. It is always positive. So if we get negative value for the numerator, then the function is negative. And if we get positive value for the numerator, then the function is positive. Now that reduces to this. This is 266,400t minus 29,400 equals to 0. Now for t equals to 1.1, we get a 0. If t is actually greater than 1.1, then what happens? That is what we have to see. So that is the function. So if we put t greater than 1.1, then we get positive value, correct? Because this will be greater than that. So when t, so we take a test point, this is 0.11. Let's take a point which is on right side of this, which could be, let us say, 0.2. And on the left side, we could say 0. Or even 0 could work for us. So we can take 0 on the left side, right? So because t is greater than or equal to 0. So if we take 0, then we get ds dt as negative, correct? So it is negative when you take 0, and it is positive when you take 0.2. So when it is negative, that means it's going down, the rate of change, the distance is decreasing, and then it is increasing. So we get a minimum at this point. Do you see that? So we have a minimum at t equals to 0.11, correct? Now what is t equals to 0.11? It is 0.11 hour. So let's write down it in minutes so that we can say how much time. So 0.11 times 60 will give us hours in minutes, which gives us 6.6 minutes. So which is equal to, let's write down, this is equals to 6.6 minutes, right? 0.11 is 6.6 minutes. Therefore, the minimum distance between the two planes will be at 12:06, right? So we can write, or approximately you can round it to 7 also. So we can say the minimum distance, so we can write down our answer is after 6.6 minutes, right? You can write seconds also there, convert 0.6 into seconds. So approximately after 6.6 minutes, that means at around 12:06, and 0.6, if you want, you can multiply that by also 60 and get 36 as answer, right? 6 times 60, which gives you 36 seconds. So if you want 6.6 and 36 seconds, right? So that is the time when the distance between the two planes will be minimum, correct? So that is how you can solve this question. I hope it's absolutely clear. Thank you.